Hey everybody, welcome back to the show. We're just about done working on the track press. That's right. There's been a lot of heavy fabrication work going on, and I decided it's high time, past time, I generated a little bit of content on it. So I have an opportunity. When you have big metal that you need to drill, you need a big drill press. That's right. This is my Camel-Back drill press. I've had this for probably 10 years now. I bought it at a swap meet. It's had its knocks, okay? It's not pristine anymore, but price was right, and I have a deep affection for quality old equipment, vintage equipment like this, and it was just neat. So you can see here the Canedy and then Otto Manufacturing Company, Chicago Heights, Illinois. So that's that. And for model, it's over here in the base. It's probably gonna be harder to see over here, but it's a XL22. That's what it is. And I don't have all the specs on it, but I know it weighs several hundred pounds. That's why shortly after I bought it, I welded up this stand for it with swivel casters, all four corners, because if you can't roll this around, you don't move it. We need to tote it around with the tractor if we're gonna take it from one building to another. And current configuration, well, I'm about 6'2", and it's about as tall as me. So it's pretty good size. And it's just a really neat old press. They call it a Camel-Back because of the frame here, and it's the old flat belt drive with the stepped pulleys for getting different speeds. We have it set for the lowest spindle speed right now because Senior got this running the other day. Like I said, we've had it for like 10 years. We got it without a motor on it, and he decided, well, I've been doing all kinds of heavy drilling anyway. Let's see if we can get that Canedy-Otto running before I'm done with this project. So he fabbed up this C-channel bracket on the bottom, put this motor on, switch down here. We just have a V-belt drive to it right now. This used to be like line shaft, all flat belt driven. It looks like they may have had a fast loose pulley on it one time, or perhaps this was for quick change, looping the belt off down here. That's what this arm was, and it would have had a rod with like a fork right here that would have slid the belt side to side. That's been broken and brazed at one time. Yeah, we're just using it basically fixed speed off the motor right now. We can change the flat belt on these steps as needed for a different speed. Like I said, we're at lower speed, but these are so nice for drilling heavy duty holes because of the rigidity in this. I mean, look at this big post right here and the table and just the bulk of everything. They're really quality old tools. And this actually has a back gear up here if you choose to use that, different speeds, what have you. And this has the power feed mechanism on the side still. This is where one of the knocks came into play, but it was a smaller belt that ran off of either one of those 3-step pulleys to these, and you can see how they love their belt dressing. We didn't bother cleaning this up because this is a little bit rough, but yeah, so your top shaft here would power your automatic feed at, well, either one of the 3 speeds that you choose. There's a ratchet pawl right here that prevents it from rotating backwards. And you have this worm gear drive right here that you can see as the belt would turn the pulleys. The pulley is geared to that shaft, in turn spins the worm gear and interfaces with this gear right here, which is attached to the main spindle. And I have a very lever and cog brain. I just love the way this works. So you press down on that, it engages it. Press the other lever, it disengages. So it's all in this little mechanism right here. We've got the spring on top. So if we go to engage it, watch this pawl right here. As we push that down, it clicks in between those 2 pieces and keeps that meshed in place. So as this would spin the pulley, we'll spin it a little bit faster by hand so you can see, it actually power feeds for depth. It power feeds the drive. And then when you're done with it, You just pull on this lever right here, and all it does is pull that little wedge out, and your return spring unmeshes the whole thing. So such a simple but clever mechanism. But this is where some of the damage came into play. We roll this gear around. Yeah, they actually stripped some teeth off of it right there. They must have bottomed this out at one point and walked away from it. And somehow the flat belt drive still had enough grip to strip the teeth off of that. So we don't use the power feed so much, but otherwise it's just kind of neat. There's some old stenciling here. It looks like a 2.0, and I believe that was a 5. Very well could have been a factory machine at one point in time, but yeah, just flat gear drive all the way down. We've been using it a bit. Let's get a rag here because we've been oiling it, and you can see there's a lot of black goo that's been working out. Of course, this had been, well, abused for a long time, and everything had sat for a long time since it had seen maintenance. So we're still working everything out of it, but that's kind of the brief walk around of it. And we're going to drill. This is one of the end abutment plates for the track press. This is 15-inch H-beam. It's a 3/4 inch thick web. We're 5/8 thick on the legs. And I've got a series of 6 holes here. I've pre-drilled pilots to 3/8 diameter. We've got a 3/4 bit in the spindle now. This is a number 3 Morse taper. That's what it looks like. All right, just taper drive. Drives up in there and seats that. So let's put it to work. Let's do some drilling. All right, first thing I love about flat belt drive equipment. Click, click, click. See that belt lace comes around? Click, click. I love those rhythmic sounds like that. Just awesome. And flat belt drive from the bottom up to the top. See power transfer through the gearing into the spindle shaft. It's actually a really smooth old machine. And you can see the slower speed on the drill. I like slower speed for larger bits like this. It's so much nicer to control. And these are so rigid, you don't get any deflection in the main frame. I like to throw cutting oil on here more to take care of the edge of the bit more than anything. But rolls some nice chips too. You can pop big holes through thick steel so fast with these. Here's where a heavy drill press is about to pay off on the breakthrough. Look at that. When you finish that plunge cut and it's just smooth, those are nice results there. So much more controllable than a hand drill. Another thing that's nice, a heavy drill press like this, you can step from that 3/8 hole up to full 3/4, and you can skip a couple sizes in between. If I was doing this with a hand drill, that'd be a pretty tall order. So let's just see how long it takes us to get another hole drilled. We could keep going, my conscience won't let me. More oil. I had to lift a little bit to keep the chip from scarring the lens on my camera. It's getting a little bit long. Break through. That's so much fun. Okay, to set up for the next job, we're going to have to raise the table, so loosen that clamp bolt. Crank on this handle to raise the table. It powers that jack screw. Jack screw lifts it on the post. Nothing about these is light enough to do by hand. They give you mechanical advantage everywhere. Come back around here and lock it in place. Next drilling operation, 6-foot chunk of T-channel. Need to do 12 more 3/4 inch holes in this. And we're going to use the track of 5J1113 to give us support out on that end. So yeah, this is going to be a little bit easier than what we just did. This is only 1/2 inch thick right here. This is T-channel half thick, 8 inches wide. We are 6 inches tall on the web by 5/16 thick. So yeah, and even a 3/4 inch bit is pretty light work for a drill like this. This is like 1 inch plus is kind of where it's in its prime. So let's get the last few holes drilled. It loves the taste of steel. Okay, here. That's a chip. Okay, here we are. So yeah, that old Canedy-Otto does a pretty good job. We've got 6 3/4 inch holes in the top of that abutment. That makes 12. 6 more on top of the brace. 13, 14, 15, 16, 17, 18 down on this end, and 6 more makes 24 total. We just popped in short order, and heavy drills are so nice like that because, like, even down here we've got, well, 12 1-inch diameter holes between the H-beam upper and H-beam lower there. That makes 24 1-inch diameter holes with everything we popped down there for all those heavy through bolts. So sure is nice when you can just sink through metal that thick with that much ease. Yes, the old Canedy-Otto, it needs some more work yet, but I don't know. I don't know if I'm going to completely restore this thing or we're just going to keep using it as it is. It almost needs another whole drill press to really make this good, and the table's been well beat down there. That's the surest sign of hackery, when you can't even make your bit go through the center hole and you're plunging marks, and the machinists don't do that. Not that I'm a machinist, but even novices shouldn't do that. Anyhow, I digress. Really neat machine. Like I said, love that old technology, and it's just so heavy duty. Well, take a look at this old Craftsman that I do like 95% of my drilling on. You know, that's the size of the tube on that. Compared to this one, you're 3 to 4 times as big around. So they're so rigid. There's no deflection, no flex. You can get some nice square cuts, and it sinks through thick steel like it's butter. So thanks for watching, everybody. We're just about done with the track press build. I just need to mount the hydraulic cylinder on it. We got the last of the hardware I was waiting for that today, and we'll be ready to see if it actually works. So we'll probably do a pretty good walk around of that whole thing and an assembly next time. Thanks for watching, everybody. Hope to see you back again.